Hello students, welcome to Learner's Planet Problem Solving Session 1 of Metals and Non-Metals. In this session children, we will be discussing questions related to the chemical properties of metals as well as their physical properties. So let's start with our first question. The question is, which of the following metals does not react with oxygen even at high temperatures? So what are the metals which do not react even at high temperatures? Say we have got here calcium. Calcium is a highly reactive metal. So it reacts with oxygen and it forms what children? It forms calcium oxide. Our next metal is gold. Now we know that gold is what children? Gold is an very less reactive metal, right? Or it is an unreactive metal. It is unaffected by steam as well as with oxygen. So what would be the right answer of this question children? It should be gold. And sodium, we know that sodium reacts with oxygen forming sodium oxide and it releases a large amount of heat. So based on the reactivity series, you can tell the answer of such type of questions. So what are the metals which are highly reactive? They are potassium, sodium, calcium, magnesium, aluminium. These are highly reactive. So they all react with oxygen, as well as your zinc, iron, tin, lead. They also react with oxygen, but their reactivity is less. Whereas the metals like copper, mercury, silver, gold, which are present below hydrogen in the reactivity series, are less reactive. Gold is the least reactive metal. So the answer to this question is what? It is gold. Now let's take up our next question. Here it is. Name any one metal which reacts neither with cold water nor with hot water but reacts when heated with steam to produce hydrogen gas. So can you suggest any metal in this regard? We know that our potassium, sodium, calcium, magnesium, these are what children? These are highly reactive metals. Even your aluminium is reactive. But just tell me give me any example of a metal which reacts only with steam. It is what children? It is iron. So answer of the first question would be, what all it can be? Below aluminium. What all are the metals children? Below aluminium there is zinc, iron, tin, lead. So in this case children, we know that these metals are reactive. Sodium, potassium, calcium, magnesium. Even your aluminium is reactive. But aluminium doesn't react with cold water. Why? Because of the formation of oxide layer. Okay. So aluminium does not react with cold water or even hot water. Why? Because of a thin layer of oxide over it. And what oxide is it children? It is aluminium oxide. So your aluminium reacts with steam producing hydrogen gas. That is, if I write the reaction, that is your aluminium plus steam, H2O. What will be the products formed children? It forms with steam, metals form their respective oxides. Am I clear? So with steam, what it is going to form? It will form its oxide. What is the formula of aluminium oxide? Aluminium oxide is Al2O3 plus of hydrogen gas. So the other metal, this is one of the examples. So any one metal, it can be aluminium or it can be zinc. Zinc also reacts with steam and it forms what? Zinc oxide and hydrogen. Right, children? So here your zinc also reacts with steam and forms what? And it forms zinc oxide and H2 gas. The same is the case with iron. Iron reacts with steam forming Fe3O4 and hydrogen. So, of these, any of the metal you can mention. Aluminium, zinc, iron, tin and lead. All of these react with steam only. Reactivity of tin and lead is very less. So, the answer of this question could be aluminium, zinc, iron. Any of them. Now moving to our next question. I hope you understood this question. So for solving questions of metals, children, what you need to remember is the arrangement of metals in the reactivity series. Now taking up our next question, aluminium containers are used for storing concentrated HNO3 by. Now we know, children, that concentrated HNO3 is a strong oxidizing agent. So what can I write here is that concentrated HNO3 nitric acid is a strong oxidizing agent. So you can't store this anywhere. So what is used is aluminium. Why? What happens that if it is stored in an aluminium vessel, your aluminium will react with HNO3 and it will get oxidized, forming what, children? It will form aluminium oxide, that is your Al2O3. Now once this layer is formed, that is what will happen now? A layer of oxide is formed. Now this layer of oxide protects aluminium from further oxidation. Getting my point? So this layer protects aluminium from further oxidation. So we can use aluminium for storing HNO3. Now what all are the products? What else are the products formed here? It will form NO2 and H2O, of course. So we can use aluminium vessels for storing concentrated HNO3. Because once aluminium gets oxidized, what it forms is aluminium oxide. And this aluminium oxide forms a layer over that aluminium. And this layer protects aluminium from further oxidation. So the answer of our question is that aluminium reacts with concentrated nitric acid forming aluminium oxide. And this aluminium oxide forms a layer over the aluminium metal, thus protecting it from further oxidation. Now let's take up our next question. It is, what happens when a piece of sodium metal is dropped into water? What will happen? So do you know what type of reaction will take place here? Sodium metal with water. Where this sodium is present in the reactivity series, it is present in the second position. It means that it is highly reactive. So your sodium metal, that is sodium, what will happen to it? This will react with water, and we all know that when metals react with water, what are the products? The products are their respective hydroxides, that is sodium hydroxide is formed plus H2 gas is released. How I'll balance this? I can make it 2 here and 2 here. Plus, as this is a very reactive metal, that is sodium is a highly reactive metal, what will happen? Large amount of heat is also released. Now, due to this heat, what happens? That the hydrogen gas starts burning. Okay, so as soon as you'll put a piece of sodium metal into water, what will happen? Explosion takes place. It is not a huge explosion like atom bomb, but it is a very minor or very small explosion takes place. Because of the heat released, the hydrogen burns. So what will be the answer? It explodes. That is, a small explosion takes place, or sodium hydroxide, it catches fire. Okay, and this is the balanced chemical equation for the reaction taking place. So, did you get this? Likewise, potassium also. If a piece of potassium is also dipped in water, potassium is more reactive than sodium. So, what will happen? This potassium will also react with water and will form what? What it is going to form? It will form potassium hydroxide, that is KOH, plus of H2 gas, plus of heat. Again, the heat released what it will do? It will burn hydrogen. So, this is your reaction of metal with hydrogen or with water. Now, let's take up our next question. It is, name any two neutral oxides. Just tell me the name of any two neutral oxide. What type of oxide is formed by metals, children? Metals. What type of oxide they form? So, metals form basic and amphoteric oxides. And what type of oxides do non-metals form? Non-metals. You must be knowing this. Non-metals form acidic and neutral oxides. So, can you suggest me any name of neutral oxide? It is, I told you, I suppose, this carbon monoxide, CO, is a neutral oxide. Nitrogen monoxide is a neutral oxide. Nitrous oxide or dinitrogen oxide, sorry, it's not nitrous, it is dinitrogen oxide, is also a neutral oxide. So, these are what? These are your neutral oxides. So, what is the answer of our question? It can be carbon monoxide or nitrogen monoxide or dinitrogen oxide. These are all what, children? These are neutral oxides. Now, let's take up our next question. Name one non-metal and one metal which are in liquid state at room temperature. Can you suggest me any non-metal which is liquid at room temperature? Any non-metal. Non-metals are actually gaseous in state. So, there are certain non-metals which are in liquid state. Which one it is? It is bromine, children, if you remember. Your bromine is in liquid state. And bromine is what? Bromine is a non-metal. And one metal which is in liquid state. Tell me any metal which is in liquid state. So, the only metal which is in liquid state is mercury. So, what is it? Mercury is a metal which is in liquid state. So, our answer of this question would be metal which is in liquid state. So, what would be the answer of our question? The non-metal which is in liquid state is bromine. And a metal which is in liquid state is mercury. Now, our next question is, name two elements that are stored in kerosene and why they are stored in kerosene. So, go to the reactivity series again. So, what are the metals which are having topmost positions in the reactivity series? They are sodium and potassium. Potassium is the first and then is your sodium. So these are the metals which are having the top positions in the reactivity series. Now these are stored in kerosene. Why? Potassium and sodium are stored in kerosene. Why they are stored in kerosene? Because when they react, when they are exposed to air, they react with oxygen of the air. And what they will form with the oxygen? They will form their respective oxides. That is, your potassium will react with oxygen and it will form, what it is going to form? It will form K2O, that is potassium oxide. Potassium also forms KO2 plus large amount of heat is evolved, right? So the heat evolved is very large and it catches fire. The reaction is vigorous. So as the reaction is vigorous, what is happening? We are storing it in kerosene so that it is not catching fire. So these two metals, likewise your sodium. Sodium also reacts with oxygen of air, forming sodium oxide, and large amount of heat is released. And because of that, it catches fire. So sodium and potassium are stored in kerosene. Now let's take up our next question. Choose neutral oxides out of the following. So carbon monoxide. I have told you that carbon monoxide is a neutral oxide. Why neutral oxide? Because it is not changing the color of litmus solution. So what is the color of litmus solution, children? It is purple when neutral. So that color is not changed. So our carbon monoxide is a neutral oxide. Carbon dioxide, what type of oxide it is? It is an acidic oxide. Now as it is an acidic oxide, what it should do? It should turn the color of litmus to red. And also, why it is an acidic oxide? Because CO2, when dissolved in water, what it forms? What is the product formed here? The product formed is H2CO3. That is what? That is carbonic acid. So it is an acidic oxide. Now our next oxide is nitrous oxide. What is nitrous oxide? The formula is NO2. NO3 is nitric oxide. NO2 is nitrous oxide. Now, what is it? What type of oxide it is? It is again an acidic oxide. Why? Because NO2 dissolves in water, giving you what? HNO2. That is nitrous acid. HNO2. And what is it, children? It is nitrous acid. So it is again an acidic oxide. Now our next oxide here is sulfur dioxide. Sulfur dioxide is SO2. This is again an acidic oxide. Why acidic? Because SO2, when dissolved in water, what it will form? It will form H2SO3, that is sulfurous acid. So this is an acid. So SO2 is an acidic oxide. Now is our nitrogen monoxide. It is NO. This NO is a neutral oxide. Then is our dinitrogen oxide. Dinitrogen oxide is N2O. This is also a neutral oxide. So what are the neutral oxides, children? The neutral oxides here are carbon monoxide, nitrogen monoxide, dinitrogen oxide. Even your NO3 is an acidic oxide. So now, and what is your P2O5? P2O5 is also an acidic oxide. Now let's take up our next question. P2O5 or P2O3 is also an acidic oxide. Now let's take up our next question. It is an iron knife is kept dipped in blue copper sulfate solution. The color of solution changes to light green. Why? Give a balanced chemical equation for the reaction taking place. Now here children, there are two elements. What are these elements? The elements here are iron and copper. Now you have to find out which is more reactive. In such type of question, here it's an example of iron and copper sulfate. It would have been copper and silver nitrate. It would have been iron and sodium sulfate. Anything it would have been. This is one sample. How to solve such type of questions. What you must remember here is the reactivity series again. So let's write the reactivity series of metals. So what are the elements and how they are arranged? It is children's potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. And after that what comes is hydrogen. And below hydrogen is what children? Copper, mercury, silver and gold. So what you have to find out is, I told you that the metals which are below are less reactive, whereas the above ones are more reactive. Right? Now the more reactive metals can displace less reactive metals from their salt solution. Now here, what are the two elements? Iron and copper. Now in this case, which is more reactive children? Iron. Because copper lies below hydrogen and iron lies above hydrogen. So what will happen? This iron knife is dipped in copper sulfate. So it would be iron plus copper sulfate. So iron being more reactive, what it will do? What it is doing, iron will displace copper from copper sulfate solution. So what is happening here is iron is displacing copper from copper sulfate solution and is forming ferrous sulfate solution. What is ferrous sulfate? Ferrous sulfate is FeSO4, or it can be also written as iron 2 sulfate. This iron 2 sulfate is a greenish solution. And what happens? Your copper solid gets deposited. So what has happened? Copper sulfate has a blue solution, or copper sulfate is a blue solution. So the color has been changed from blue to green. Why? Because of the formation of ferrous sulfate. Why? Because iron is more reactive than copper. It displaces copper from its salt solution. So every time when such type of questions are given, what you have to remember is the reactivity series. This you should remember children. You have to remember this. Now let's take up our next question here. An element X on reacting with oxygen forms an oxide X2O. When you have got such essay type questions, that is the question which is more than the length, whose length is more than 3 or 4 lines, then keep on writing after every step. So what is our first line? That an element X reacts with oxygen and it is forming an oxide of formula X2O. Now children, this is forming X2O. What does this mean? That what is the valency of your X here? The valency of X is 1. And the valency of O is 2, of course. This oxide, our next point is, this oxide dissolves in water and turns blue litmus red. So, state whether element X is a metal or a non-metal. Just tell me it should be a metal or a non-metal. It is turning your blue litmus red. When the litmus paper, the color of the litmus paper is changed to red, it means that oxide is an acidic oxide, right? And I think the formula should be X2O3. Valency of X will become 3 here. The question should be, an element X on reacting with oxygen forms an oxide X2O3. This oxide dissolves in water and turns blue litmus red. Blue litmus red means on dissolving in water, it is forming an alkaline solution. And so that alkaline solution is changing a blue litmus red. What does this mean? That it is an acid. So what is it? It is a metal or a non-metal? It is a non-metal. Metals form an oxide which is basic in nature. So here children, the formula of the oxide can be XO2 or X2O3. X2O3 doesn't mean that it's aluminium only. It can be any other oxide. It can be boron oxide also. It can be gallium oxide also. So if it's boron oxide, it is turning blue litmus red, means it is acidic. So the formula can be XO2 or X2O3. What you have to keep in mind here is that it is dissolving in water and turning blue litmus red. Had it been red litmus blue, so what would have been X? X would have been a metal. But it is turning blue litmus red. It means X is what? X is a non-metal. Getting my point? Because acids turn blue litmus red. Let's take up our next question here. Metals replace hydrogen from acid whereas non-metals do not. Why? Now I discussed in my theory session that what metals do is. So metals form what type of ions, children? Metals form electropositive ions. That is M plus or M2 plus or M3 plus. Now in this process, what are they doing? They are releasing electron. 1 electron or 2 electron or 3 electrons. Now what these electrons do? These electrons reduce H ions from acids. So H ions are obtained from where? H ions are obtained from acids. So what are they doing? They are reducing H ions from acids, forming hydrogen gas. Say for example, I have an acid that is H2SO4. Now this H2SO4 on dissociation gives what, children? It gives 2H plus of SO4 2 minus. Now this 2H plus accepts 2 electrons from metals and gets reduced to hydrogen. Whereas non-metals do not. Why non-metals do not release? Because I told you that non-metals form what type of ions? They form negative ions. How they will form negative ion? By accepting electrons. So, say taking an example of any non-metal, that is oxygen. This takes up 2 electrons and it forms what, children? It will form negative ion, that is O2 minus. So, oxygen will take up 2 electron and will form O2 minus ion. So, it is not releasing any electron. So, if they are not losing electron, how can they reduce hydrogen? That is why non-metals do not release hydrogen from acids, whereas metals release hydrogen from acids. So, what will be the answer? Metals form a one-liner, metals form electro or metals form positive ions. So they release hydrogen from acids, whereas non-metals form negative ions, so they cannot release hydrogen from acids. So I hope you would have enjoyed solving these questions. We'll be meeting for our next problem solving session, in which we will discuss few more questions. Thank you, children, for your patience, and I hope you'll solve few more questions related to metals and non-metals.